And we are currently recording. And Anand and Matt are both here and will be co-hosting. So the only announcement that we have at the moment is we've decided for KubeCon that we're going to do a joint session for both the intro and for the deep dive. And the thinking behind this is that we know we've done the split sessions before, and we wanted to get data on how well the joint session would run. There didn't seem to be too many objections to this, and all the chairs kind of agreed that we'd like to try it this time. So in Barcelona, which is coming up in May, showing for the conference, you should come, you should attend the SIG Apps deep dive and intro. We're going to do the joint session. Okay. Now for the workloads API discussion. So we still have this kept open with sidecars. I think Anthony from, or Inasak, Anthony Yee from SIG Apps has been largely involved from the SIG Apps side of the sidecar implementation. It looks fairly implementable. Some of the feedback that I got from SIG architecture was that I think they'll be okay with the API modification in order to implement sidecars, provided that we don't try to do an arbitrary like systemd style graph of container ordering, and we just have two tiers. The feedback was that it implements a real use case and therefore is valuable. Were there any other thoughts on this, or have people been following this CAP in the community?
Maybe a question, like, what is SIGBot saying on this, or SIGNode, whatever we have, because this kind of falls underneath them as well, right? So this has been transferred, or? So
Derek and Don, neither of them seem to be against it. Let me get the CAP.
If you could just link the issue, if you have it at hand, because I don't see it in the
so
meeting.
There's an issue as well as a CAP. Let me get the first get the CAP. And the CAP is under SIG Apps. But let me link that into first the chat. So Joseph linked the issue, and then, yeah, there's the CAP. So I mean, my thought is to allow sidecar equal true. We only have two really tiers of this. That seems not to be too controversial. There are some issues with readiness in terms of the CAP as it is right now that probably need to be addressed. As in, right now it doesn't talk about if the pod has a readiness, well, do we respect the readiness of a sidecar? How does that fit into the life cycle of a sidecar container when interacting with other containers? My thought kind of is that if you're not going to respect readiness and wait for the container to become ready before you launch the other containers, you probably, for the sake of some of its uses, are no better off than you were before.
Yep, that sounds reasonable. I think there's quite a few stages of how we could implement it as well. Not everything needs to be done at once, so to speak. It's kind of disconnected in terms of like shutdown, ordering, and stuff around like the pre-stop hooks. Just to let you, from the SIG node side, Derek seems fairly supportive. We and him were talking about how we would go about implementing this week in terms of getting like a POC branch going and iterating on that, linking to that beyond the KEP. We're just waiting for Dawn to kind of give us the go ahead. We haven't managed to catch her at a SIG node meeting in a while, and Derek would just like her to kind of officially stamp her seal of approval before we start going.
She's a very busy woman, but let me see if I can chase her down. The last time I talked to her, she, again, as long as we're not trying to implement that container D style level of arbitrary hierarchies of pod dependencies, seem generally supportive.
Yeah, I've had a few people kind of pushing for the system D style, but I don't think anyone so far has come up with like a very kind of concrete use case of why they need that, while the kind of more simple sidecar tree approach seems to fit most people's problems that they're seeing.
Right, and if you look at Tim's feedback, Tim Hawkins, he basically feels the same way, that like if we go and do the sidecar equal true, it fits the job and daemon set use case pretty well. Having two kind of levels of two tiers of things, like I start all my sidecars first and wait for them to be ready before I start the containers they depend on, makes sense. Going arbitrarily deep, the additional complexity probably outweighs the benefit. I kind of agree with that too. Okay, so next we wanted to talk about, hold on for a second.
I had a few comments on the chat.
Sure.
So one thing, when I see sidecar, I don't really know what's going on. I say sidecar true. I don't know it's about ordering, or even like the sidecar would be like the first time we like more or less officially introduce this term about what kind of expectation we have behind this. And I feel like some different users are different kind of thinking about what a sidecar is doing. So I would prefer something more related to ordering or dependencies rather than say sidecar true. And the second comment is, as you say, maybe we don't need like to express all the dependencies in the code, but just in terms of evolution of those things, if there is feature request later and we just implement it as a Boolean sidecar true, it would be more complex to move forward. So maybe we implement just one kind of dependency, but just in terms of how the wording and the type of the field, we should be able to extend it later on.
Yeah, so the sidecar equal true thing is just a way to express the general concept. We may have something instead, like it calls out in the KEP or in the issue that we could actually do something like pod lifecycle equals sidecar, right? I mean, and that would probably be what ends up getting implemented more than the Boolean flag, for the reasons you just suggested.
Okay, that was just my comment. So yeah, I would prefer like a field very expressing the behavior and something that can be extended later.
Sounds reasonable. Okay, so next we have the max surge for stateful set. Did anyone, so have people looked at this? Are they familiar with the concept?
Yeah.
So the idea,
could you sell the reason why we want it for stateful set? I think I saw the issue once, but it was a while back.
well,
Because right now stateful sets do one by one, and
this is actually worded wrong. It's max unavailable for stateful set.
all right.
So they want to allow multiple pods to be unavailable for a stateful set in order to allow, and I'll link this in order to allow more than one pod to be down during the rolling update, right? So like we have the mode in stateful set spec. There's a mode that says burstable, which means basically I really don't care about ordering. I just want unique identities. So it'll allow you to roll things over in terms of starting the stateful set up fast or tearing it down fast. But we still try to go, we provide the ordering guarantees when we go basically strip mine the stateful set to update it. This would allow you to do more than one pod simultaneously. And the thought behind it is that it allows you to do the same thing that you do with daemon set or deployment in terms of trade disruption for velocity, right? Like I'm willing to have a greater amount of disruption in my stateful set to improve the velocity of my rollouts. I kind of like, I think that there is definitely a real use case for it in terms of, you know, people do have largest stateful sets where the restart times and container image pool times kind of make it very difficult in order to do a rollout in a timely manner. So providing the ability to surge, to tolerate more unavailable stateful sets would probably, and surge would probably allow you to go faster than you would previously and complete your rollouts faster if you can tolerate that amount of disruption.
I think my thought to this is like stateful sets are all one by one, and they do it to maintain quorum, right? So really, to need more than one, you would have to have like you would have to at least 10 pods, so this starts to matter, right? Because if you start rolling out more than one, you run into quorum issues. If you misconfigure, you lose your stateful set. So this would be like a really easy way to lose quorum, right?
Agreed. Like if you restrict, I guess it's kind of conceptually, what do we want to do with stateful set from that perspective, right? Do we want to say that really it's for distributed systems where there is a relatively low tolerance to disruption, and we expect that when you're doing a rolling update, you'd rather definitely have one-by-one semantics than you would to be able to be more disruptive and trade for velocity? Or do we want to incorporate other use cases where you're not going to lose quorum or you're not going to lose consensus, but what you'll end up, you're using stateful set not for consensus mechanics, but primarily to just make use of the stable network identity and the storage provisioning, which is actually a large portion of use cases. It's non-trivial. So if we want to support it, we might want to think about actually adding better support for doing the updates.
Like it makes sense, and I'm not against it. I'm just saying we should think this through so there are no unexpected, well, rollouts of stateful set that lose quorum or stuff like that, because that would and I would like it to be based by real use cases that can't be covered with the other workloads.
So in addition to the cap, there are at least 2 or 3 issues that are open in the community that point to it. And based on where it's coming from, I'm fairly sure that this is something that the user needs for a production system based on the prior requests they've had for the workloads APIs. Again, I haven't seen somebody saying it's just like a nice to have or something we want to polish off the API for consistency. We considered that before we went V1 and we're like, it's more important to have the semantics of ordered rollouts than it is to have consistency and potentially introduce dangerous semantics. But now we're at V1. If we added this, it would be sort of an opt-in. It wouldn't be something that would be on by default. But the default behavior would still be what it is, and you would have to add in additional fields in order to progress the stateful set faster. in terms of the code complexity for implementation, I really don't think it'd probably be that bad. But the KEP is here. People should feel free to chime in, and we should probably see if we want to do this, and if we do, get it on the roadmap for subsequent release.
All right, I will get back to you on the cap, because
Okay.
maybe if you could just link the cap next time to the minutes.
It's in the minutes.
I added it to the minutes while we were talking if you need to get to it.
I was looking before the meeting, but I could have Googled it as well.
Okay. And then lastly, cron job GA. The person who's writing the KEPA said they will get it out by the end of the week. It's kind of lagging still. That's our fault. I apologize for that. We will try to get this expedited. We'd like to get the roadmap rolled out so that we can be assured that we try to hit GA within the 2019 timeframe. Okay, I think, does anyone have anything else they'd like to discuss for the workloads API? Going once, going twice. Okay. Does someone want to talk about Kudo Builder?
Thanks, Ken. Yeah, I'd like to go through some slides and then do a little demo for everyone.
Was this previously called something else?
It was. Maestro was the original announcement, but there were some naming conflicts with Cloud 66. They have another product as well. Let me share screen. Step 3. You'll excuse the background noise. Can everyone see the slides? They're also linked in the meeting minutes.
Yes, we can.
Thank you. So Kudo is an operator that we're building that's specifically designed to help provide operations to operators. Might be a cheesy way to say it, but we want to try and capture the actions that are required for managing applications in production as part of the deployment for the applications themselves, and be able to embed those best practices in the operator CRD definition. So Kudo is the operator that handles these specs that are provided as declarative CRDs. And we'll go through a couple examples of those. From the SRE book, you really want to have, this is like a pitch for DevOps, right? You want your developers lock in step with operations, but at some point that doesn't scale when you're trying to release these applications in larger customer bases. So the more you can provide in the binary, quote unquote, for release, allows better application operations in there. Other use cases for this brought up at the SIG Apps meeting in KubeCon. People want to be able to execute jobs on demand and have those jobs be the same as the cron jobs. So being able to provide those as one unit and execute those on demand. Canary or blue-green deployments defined by the application developers who know the right way to go about coordinating those updates, and then be able to do those same sort of updates on config map changes. So be able to put that process in place to be able to test out config changes. Those are all issues, requests, feature requests in the community that aren't going to be handled by core, I don't think, but we want to provide that mechanism in place to handle that in the operator spec. So when would someone want to use this? When kubectl apply isn't quite enough to manage your application. If you're just applying the same YAML on updates, you can probably continue to do that and not worry about it, and then just manage it with a GitOps type feel. You know, you've got these specific data intensive operations that you want to handle. A lot of the applications that we see value here interact with external data sources and you want to be able to back up or restore. You want to be able to upload jars for batch execution, like in a Flink example. But you don't really want to write your whole operator for this. You just want to be able to basically script out, quote unquote, what you would do in kubectl or customized speak to get that into production or do that update. So the vision is that they're going to have two CRDs that are defined in the Kudo spec for your application. You've got a high-level framework object, and then you've got particular implementations of that framework in versions. And then together, those are going to go and dynamically create a CRD in your cluster with a particular version. So you'd have a zookeeper, you'd have a couple versions, and then you'd be able to get particular API versions of that CRD object dynamically generated, and then you can instantiate CRDs of that type. Eventually, or it's not quite there yet. So right now we have a wrapper linker object called an instance CRD that kind of ties an application instantiation to a framework version, where we like to consolidate that and make specific CRDs instead of having this linker. The framework version spec. So this idea of plans is really at the core of what Kudo wants to do. It wants to create these actionable task lists in Kubernetes speak of things that you want to do. So you can have separate serial or parallel deployment strategies and do all these steps at the same time, or wait for one to get healthy before continuing on to the next. So in this particular example, you do a deploy and you wait for that deployment, whatever it is, to get healthy before you run a task called init. And you can go and define that later. You can define separate backup and restore strategies so that you can embed how to do those processes inside your framework version. Tasks are right now just references to YAML. Customized patches are on the roadmap. We would like to be able to reuse a lot of that language that's in there for customize, to be able to reuse a lot of YAML and just template out the command that gets executed rather than having to redefine all that over and over again. So this would be some example of tasks that get defined. And when you instantiate your instance, you're going to be setting these parameters. You define your parameter spec, default values, descriptions that could be used in some UI components, required whether you need it or not in your instance, whether it has to be provided or whether it can be set to default or dynamically generated. And then a trigger. So when I update this value in an instance, what plan should I run? And this lets you customize. Well, if I'm just scaling up my instance, I just roll a new deploy out there. If I want to update the image tag or change this to a big value, I want to execute a different plan that does things a little bit more smoothly and with a little bit more checks along the way. And then you reference those right now, mustached. We've had some requests for templating instead. The power of that seems to be a little stronger, so that's been talked about. And then inside the hood, the operator just parses this mustache, throws it into customize, and spits out YAML that gets applied. And we wait for health checks, and then we continue on the step process. Yeah. So right now, our instance object is this linker. You got a reference to the framework version that it implements, rather than having that be the API version. You provide some parameters. In the future, we want that embedded as part of the object. So you can see the definition for the framework version is specific up there. And then you provide the parameters as part of the spec of the object. Do a quick demo with some MySQL stuff. So this is going to create 3 objects, 3 CRDs. One is a framework for MySQL. One is the version, so that's 5.7, and we added some of those plans in there for backup and restore, how to deploy MySQL with the service and all those other things that would be required to leverage MySQL as an instance. So the actual deployment, if you guys are in the repo, there's an initiation step that actually creates a database inside of the MySQL instance. We could have done that by embedding that startup script in the MySQL init folder. This kind of lets you reuse that common MySQL image and still provide that value or that capability. So we didn't have to recompile anything specific to get that default schema in place. So it ran that job. We're gonna just get a couple variable sets so that we can do things. The init then created a table in that database called example. So we can add some data in there. We'll show the backup and restore process. A little slow right now. So we added 4 random events in there. We're going to instantiate a backup. So that created one of these plan executions, which actually executes the plan, and you can keep track of what that looks like. So there's the backup. Probably missed it already. So it creates a job and then cleans up that job once it's done. So you have the capability to delete objects as part of this step, which is something that I've had use for in various applications. Do cleanups once you start modifying what your objects as a whole should look like. You're not just updating each object. Sometimes you need to remove objects. So that gives you that capability. So we did the backup, so we'll just do another sanity check that the data's still there. And then we're going to do a delete of all the data in our schema in our table. So there's nothing there anymore. So now we've done a backup, and now we want to do a restore on that backup, so we can start with the restore plan. Again, that was provided as part of the definition for the framework version. Did I miss it? I already had the image pulled, so it runs exceptionally quickly. So I forgot, I started talking again. That's always my problem. And we were able to then restore from that last snapshot. Okay. Link to GitHubs. Those are people that were working on it. Toby, Jared, Jorgen, and Fabi, I think are both on the call. We're definitely looking for help for different use cases and helping out with different actions that people are looking for. We don't have canaries fully implemented yet, or an example of that, but we'd like to, there was 1 or 2 features that we needed to add along the way to get those, but we're close on that. We want to create application CRDs so that these instances are consumable by all the external tools that use those. We need to get a testing suite in there, obviously. But dependencies, I think, is going to be one that we'd like a lot of community feedback on. What's the right way to be able to reference another instance or CRD and have that connection string be coherent coming out, so that when I have a Kafka instance, how do I extract that broker string? You know, when I have a MySQL, how do I know what the connection URL should be? So along those lines are for generating connection strings from an instance or an application CRD. Questions? Thoughts?
Well,
Yes, Ken, I see a hand.
so when I create a framework, the framework is actually creating new CRDs?
That's the eventual goal. We want each framework version, so one of those versions of a framework, to be a different API version of a common CRD that gets mapped to the framework. And that was here. So a framework creates a CRD, and then the versions of those are defined by the framework version.
So from an RBAC perspective, how would that work? Like, if you do CRD create is like a pretty heavy administrator privilege, because effectively you're modifying the resources that the API machinery knows about, right? And CRDs are cluster scoped, right? They're not namespaced. So anything that you apply there, if you're using a namespaced model of tenancy, propagates across the entire cluster. And the API machinery thinking is that's what was designed. That's what we've got now. So if you were going to try to do it dynamically, or if that's your end objective, how would you deal with, like, would the general framework run kind of as a cluster administrator? And then
yeah, we
how
have
would you
to
deal
dive
with
into that dynamic portion a little bit better. Right now, everything is namespaced because we were implementing it and getting prototypes. So for the current capability, every framework and framework version are all namespaced and instance. And the permissions for the operator will be only creating objects that are in your namespace, and deletion can only happen on objects in the namespace that the instance is in. So we kind of have a little bit of an idea about where that lives. And that kind of solves one of the challenges we were talking about last week with namespace versions of these operators. And there's a lot of challenges there because people want to be able to create these operators, and people are telling developers to go make these. But then you require sysadmin capabilities to install. I think we want to go long-term dynamic because that seems cleaner, but the permissions thing that you're bringing up is definitely one of the advantages for our current implementation. And we're not really sure the overall trade space for everybody's use cases on what works and what people like. But we're definitely interested in trying to figure out the right trade-off there between the flexibility of having application operators deploy their own versions in their own namespaces to manage versus having this broad capability from a cluster perspective that, easily defining these framework versions in YAML gives you the capability to provide full operators to everyone on the cluster and be able to give those application management pieces to those application operators as well, and not have to provide support on each one of those.
So the typical model right now is that the custom resource definition that describes the workload is installed by an administrator, and potentially the orchestration component, the controller itself, would be administrator installed. Then RBAC gets granted to individual namespaces or cluster-wide, but basically to whatever principles you want, to be able to create the custom resources that trigger the automation to turn the workload up. How this is differing. Like, are you turning up an individual controller per workload? Is that the tenancy model?
We're going to have one controller that handles all of the CRDs of this type. So they're all going to be spit through the same state machine and be subscribed by the single operator. And right now that's really clear because there's only an instance CRD, so that object is clearly owned by the one operator. But once we start doing dynamic, there's going to have to register for all of those new ones that come out along the way.
Interesting. Cool. Awesome demo.
Well, any other questions? All right. Thank you, guys.
Thank you. Okay, and for discussions, which is the last portion of the meeting today, we wanted to talk about volume resizing with respect to stateful set and what we want to do there. There is a PR open and a CAP open, I believe, actually I'm not sure if they were to CAP for this one. In order to have stateful set dynamically update pods, will kill pods and restart them in order to make use of the ability to resize persistent volumes via volume claims template. And there's a couple of steps that are going to happen here to make that work. But there's kind of there are two ways that we could actually go about this. So right now, the only way you'd actually be able to consume a larger volume is by restarting the pod. You basically are going to have to reconstruct the file system for most implementations in order to make use of the larger volume size. Online file system resizing isn't largely supported across most cloud providers as far as I know. But it seems from SIG storage, the direction they're going is to support online file system resizing, which would mean that effectively from the perspective of the stateful set user, when you update the volume claims template, we would have to update the persistent volume claim, which would eventually cause the persistent volume to get updated. But with the online file system resizing, what that would end up looking like is it would work in place without having to restart the pod, which is actually kind of a very different thing from the life cycle of any of the workload controllers that we have right now. The only thing that we really let you update in place would be image. And even that, like the workload controllers don't respect that, but as far as the capabilities of kubelet go, you can do an in-place image update. You can't do in-place container resizing or any of that stuff. That doesn't work. So for the resources that we do provisioning for, we would have kind of a difference if we go that route in terms of we have this one thing that we would let you do online without actually restarting the pod. And it's not necessarily clear to me that many applications would actually benefit from that approach anyway, or be able to make use of it. Like, if you're doing something like MySQL or PostgreSQL, generally the amount of shared buffer that you use is a configuration parameter to the application that's independent of the underlying file system size, right? So if you have to increase your MySQL, or I'm sorry, your Postgres shared buffers in order to make use of that increased memory or file system size, databases tend not to, except for maybe like log structured merge trees, tend not to utilize the file system anyway. Like Linux kernel maintainers yell at database developers all the time, don't use a file system, write directly to block and implement your own page cache because you have special needs, and we're not going to modify the Linux page cache in order to support, the workload use cases that you have. So I'm just kind of looking for people to give feedback on, do we think we want to do the restart and that would be more consistent with kind of what we do for everything else? Do we think we want to do nothing and wait for online resizing to become available? And then maybe we probably need to come up with a plan to actually implement this in a way that is backward compatible across releases and allows us to do it in a safe way. Because right now, the volume claims template for a stateful set is not mutable. So in order to do this with with multiple API servers running in the same cluster, we have to relax validation on that for at least a release, I think, in order to guarantee that you could do a minor release upgrade and have a version skew between your API servers and not break on validation when the update goes into place. Then we could roll out the actual logic as an alpha that would implement the volume resize via requesting new PDs. And then we could implement automatic restart thereafter. So, I mean, we're talking about something that would probably take 3 releases at minimum to get to like a beta state. Or we could just wait for a volume resizing for a year. So, thoughts, comments? People want time to look at the cap and give feedback.
Could you repeat what the SIG architecture guidance was around the online resizing? I missed that when you were talking.
I didn't talk to SIG architecture about it yet. I only talked to the storage people about what their thoughts were. Because, I mean, they're kind of real. I don't know if SIG architecture is super interested in the details of volume resizing, other than maybe consistency. And from the API perspective, it is consistent. So the storage guys seem very motivated to do online file system resizing. But I don't know when that's actually going to roll out. And if we do it, it does provide sort of an inconsistent semantic for all the other mutations that we do. And I'm not sure that it's desirable. And people may want their pods restarted.
Let's just discuss the point. Why is it incompatible with, well, not in line with what we do with the other controllers? Like right now we say request for the storage. It means at least say 1 gigabyte. If the online resizing makes it bigger, I don't care, right? It doesn't change the stateful set spec.
But it does, right? Like it changes the volume claims template. So we would update all of the PVCs. So right now, like step one, we could relax mutation on the volume claims template, and step two, or sorry, relax the validation on the volume claims template. And step two, we could just implement the PVC resizing in place by adjusting the persistent volume claims that are generated by the claims template, right? And then do nothing. Like if you want to make use of it, you can mutate your pod or whatever. But really, you have to, I think, unmount the volume and kill the pod in order to get the new volume. Like, I don't think the resize actually works unless you topple the pod over at this point without online file system resizing.
I'm not sure how that actually goes down. But so for the offline, we do what you said, right? We just relax the validation. You change the spec, and we will update the persistent volume claims in a rolling update fashion, right?
Yep.
That's pretty simple. I'm not sure how the online resizing goes actually, and why would it be incompatible? Because would you actually have to change the stateful set spec to achieve the online resizing, or that would be just on the background without restarting the pod?
Yeah, it would just be on the background, right? So if we start with, we're going to restart everywhere, then you get online file system resizing, you would have to add maybe another option to tell it to not restart the pods. That would be the concern if you go one way and then say, we pivot and say, okay, well, we're going to support online and in place. To me, I mean, like, basically, the benefit to being able to do the online file system resize, and we're not sure that many workloads would actually be able to make use of that, mind you, would be that you would have a less disruptive way to resize your volumes.
So the online thing, does it actually change the volume claim or no?
The what?
Or it only changes the volume mounted on the node?
With or without online file system resizing?
With online. I'm not sure
With
how.
online, it would actually like resize the file system in place, to my understanding.
Without any changes to our API objects.
Well, so it's not clear to me how online file system resizing would actually work, right? Like you may have to, like, would that be by default? Is that a global request? Would you set it per workload? Like, would your volume claim allow online resizing on it? I'm not sure what the API looks like yet. Or if even at a provisioner level, if the CSI implementation, for instance, would support multiple nodes, like you only do file system resizing for some stateful sets and not for others.
I guess without actually knowing how the online resizing works and if it needs to change the stateful set object, I can't decide if it's a good thing or not for us. Like, it could.
I don't think it would. Well, I don't think it'll change the stateful set API, right? Like, I think ultimately whatever they do is going to have to go into persistent volume claim and persistent volume at the storage layer. But the volume claims template is basically a persistent volume claim. So if they're changing that V1 API, it kind of de facto modifies the stateful set API, right?
Yeah, and we do the reconciliation on changes, right? If we see persistent volume that doesn't match what we have, we probably, I don't know, we probably stop the rollout because we can't recreate it to match what the stateful set says. So to me, it depends if the auto-resizing will actually modify the volume claims or just they could just do something like, you have a file system, there is 90% full, we will just make it bigger without actually changing the persistent volume. In that case, like,
that's not the direction they're going. They're not going to try to do storage resize in place based on disk pressure. So that's maybe one day someone would implement something like that, but that's not what they're trying to do right now. It's more along the lines of if you request, so right now you can actually request a larger volume, and I think it requires a container restart to consume it, but they can resize your disk in place. Well, not in place, they can resize your disk for you. And that's valuable, right? Because a lot of people start with an example or start with something where they provisioned far too little storage. And the story right now for most cloud providers and most on-prem instances is that, like, sure, you can go ahead and resize the volume manually under the hood, but it doesn't really, it's not reflected in the Kubernetes API objects. So allowing the mutation to occur via API objects and the reprovisioning to occur via CSI and the PDC controller, it's generally across the community been looked at as something that's helpful for people that are using the workloads, right? So, I mean, I'm fairly supportive of, we need to integrate well with this feature to provide, you know, our users a good experience when they're trying to resize their disk resource, in the same way we try to do that if they're trying to resize mem or CPU. But I don't know if like optimizing for the online disk makes sense. And if that's not the case, then maybe the best thing to do is, like you said, just do the rolling restart right now to consume it.
But we don't allow modifying the persistent volume claim, right? As you said.
We don't, but so that would be, again, step one would be to lift that, right? Like the first thing we'd have to do is lift the validation, and that would have to happen prior to rolling out any feature that consumed it to ensure consistency with a version skew of 1 for API servers and a multi-API server cluster. So that's pretty much step 1. Is relax the validation. Step 2 would be to do something with it.
Yeah, sure. Like, as you say, the story makes sense. Like, you would want to change the size at some point. Is there a cap for this, or?
Yeah, I think it's in the docs. If not, let me grab it. Yeah, it's linked.
Yeah, but like, as you say, this makes sense. There's a pretty long path to actually do this, because I guess we just need to decide if this is a use case we want and agree on loosening the restrictions or boundaries.
Yes. Okay. Anybody else have anything else on this topic or any other discussion topics they want to cover in the next like 9-10 minutes? Okay. If that's the case, does anybody want to get 9 or 10 minutes back for their Monday morning?
I will take it.
You'll take it. Okay, everyone. Thanks for attending. Thanks for the awesome demos, or demo as the case may be. We'll see you guys next week. Have a good week.
Thanks, Ken. See you.
Yeah.